Hello guys, my name is Samson and welcome to Chemistry with Samson. In this lesson, we are going to continue with the discontinuity in a trend of first ionization energy across a period. In our first or previous lesson on this same topic, we discussed the discontinuity or irregularity or the discrepancy that exists across the period in terms of an increase in first ionization energy. And we discussed beryllium and then boron. Now, let's also discuss nitrogen and then oxygen. But before we talk about the trend in ionization energy between nitrogen and oxygen, let's discuss some basic concepts. So once you consider the 2p atomic orbital, so this is the 2px, this is 2py, and then this is 2pz. Let's label this A. And then I have another diagram here. Two px, 2py, and then 2pz. And then let's have another diagram here. 2px, 2py, and then 2pz. So this is B, and then this is C. In A, I have orbital arrangement like this. Now, I have three configurations illustrated for A, B, and then C. Is that okay? We could see that for A, we have two electrons being indicated by the spins here, here as well. So it means that in terms of electron configuration, I'll put up written 2px2, 2py2, 2pz2. Here 2px1, 2py1, 2pz1, 2px2, 2py1, and 2pz1. Is that okay? So this one illustrates a fully filled orbital, a fully filled 2px, 2py, and then 2pz orbital. So this one is fully filled. So this is fully filled. And then once we come to B, we have 1, 1, 1 each. That is half filled. So this one becomes half filled. And then once we get here, one is fully filled, but the remaining ones are not fully filled. It is called partially filled. In terms of stability, fully filled atomic orbitals are more stable, or they are very stable, followed by half-filled atomic orbitals. And half-filled atomic orbitals are also more stable than partially filled atomic orbital. Please don't forget, fully filled is greater in terms of stability than half-filled. And half-filled is also greater in terms of stability than partially filled. Is that okay? So when an element or an atom exhibits a fully filled orbital configuration, it means that element is more stable or very stable compared to an element which exhibits a half-filled. So in terms of stability, fully filled is more stable than half-filled. And half-filled is also more stable than partially filled. Is that okay? So based on this idea, let's first of all talk about the first ionization energy between nitrogen and then oxygen. According to the general trend, we said first ionization energy gradually increases from the left-hand side to the right-hand side on the periodic table, which means that oxygen is expected to have a higher first ionization energy than nitrogen. That is a general trend. So according to the general trend, oxygen has a higher first ionization energy than nitrogen. Is that okay? But let's consider their electron arrangement and let's see something. Is that okay? So now, considering the electron arrangement for nitrogen and then oxygen, let's start with nitrogen. So nitrogen, atomic number 7, it has a configuration 1s2, 2s2, 2px, 2py, and then 2pz, 1, 1, 1. That is applying the Hans rule of maximum multiplicity. Now when it comes to oxygen, atomic number 8, it has a configuration 1s2, 2s2, 2px, 2py, and then 2pz. We have 2 for the x, 1 for the y, and then 1 for the z. Is that okay? Meaning that this orbital here can be replaced if you are using only the Albert principle, it becomes 2p3. Is that okay? And if you are using only the Albert principle, this one also becomes 2p4. Now, let's continue. So, looking at these two electron arrangements over here, the last orbital in which an electron can be removed, the first electron can be removed for nitrogen is in the 2p3 atomic orbital. And that is split here according to Hans rule. And for oxygen, it's in the 2p4 atomic orbital. And that is also split here according to the Hans rule of maximum multiplicity. Also, we could see that this electron arrangement here corresponds to a half-filled orbital arrangement. Is that okay? 2px1, 2py1, 2pz1 corresponds to half-filled. And once we consider that of the oxygen in the 2p4 atomic orbital, we have a partially filled. It corresponds to partially filled. Is that okay? So, for nitrogen, half filled, for oxygen, partially filled. And since half filled orbitals, in terms of the electron arrangements, are more stable than the partially filled orbital arrangement in terms of the electrons, we expect this one to be highly stable or very stable compared to the oxygen. Okay, so the electron to be removed in nitrogen is coming from the 2p3 atomic orbital, and that of oxygen is coming from the 2p4. And again, I said once you look at the electron arrangement here, this one corresponds to a half-filled orbital. So the 2p3 orbital is half-filled, and the 2p4 orbital is partially filled. So the first electron to be removed in this is coming from a half-filled 2p3 atomic orbital, and the first electron to be removed here is coming from a partially filled 2p4 atomic orbital. And what did we say? We said that fully filled is greater than half filled in terms of stability, and half filled is also greater than partially filled in terms of stability, meaning that this half-filled orbital arrangement here is more stable than the partially filled here. So the energy that we need to remove an electron from this half-filled atomic orbital will be high because of the stability of the electron arrangements in the orbital compared to the stability we have here. So here we require a lesser energy compared to the energy that we use here. Is that okay? So for nitrogen, since it has a half-filled electron arrangement in its 2p orbital, it is more stable than the electron arrangement in the oxygen, which corresponds to a partially filled electron arrangement. So therefore, much energy will be needed to remove an electron in the half-filled electron arrangement than the partially filled electron arrangement in oxygen. So we can therefore say that the first ionization energy in nitrogen is rather expected to be greater than that of oxygen. Is that okay? And this goes against the general trend. That is why it is a discrepancy or an irregularity in the trend based on electron stability. Is that okay? Based on electron stability. Based on the same idea, you should also try phosphorus and sulfur. So your try work should be phosphorus and sulfur. you can write the electron arrangement for phosphorus and then for sulfur, and then you first of all look at the general trend in first ionization energy across the three elements. Then figure out phosphorus and then sulfur using half filled and then partially filled. You know the one that is having a higher first ionization energy than the other. Alright, so in summary, we said fully filled orbitals are more stable than half-filled orbitals, and half-filled orbitals are also more stable than partially filled orbitals. In general, ionization energy increases from the left-hand side to the right-hand side, and we expect oxygen to have a higher first ionization energy than nitrogen. But once you consider the electron arrangement in the orbitals of both nitrogen and then oxygen, we could see that for nitrogen it has a half-filled electron arrangement in the last orbital, the 2p, and for oxygen it has a partially filled electron arrangement in the 2p. And since half-filled are more stable than partially filled, it will require more energy to remove an electron in a half-filled 2p orbital in nitrogen than an electron in the partially filled 2p orbital in oxygen. Therefore, nitrogen should rather have a higher first ionization energy than oxygen. Is that okay? Thank you. If you have any question regarding this, you can drop a comment and then I will attend to that as well. And again, if it's your first time visiting our channel, please don't forget to subscribe to our channel. You can like and then share as well. Thank you very much.